supposed to be doing this week. So let me get to the right screen here. We're going to put it up on your screen. Going to the grade screen in Buzz. Easiest place to find that. April 10th is this weekend. So what's due is 806 and 807 using surveys and using experiments. You'll see that's the last of our Unit 8 because next week is the practice test and the actual test for statistics. So we're about to wrap up the statistic unit here with these two lessons this week. I do want to point out, if you're not looking at, activities. If you're not looking at the lesson summaries, you're doing things the hard way because it gives you any new equations that have been introduced. So I'm going to the lesson here, 806 lesson. And there's the essential questions and information. Gives you problems to work with the answers. I want to go over to page 3. Because on page 3, after you learn an introduction, methodology, results, and discussion, you need to know those 4 things there because there's a question on that on the assignment. The lesson summary right here. I think that's bigger on the screen. Let me see more of it. But we're looking at population proportions. Population proportions, the proportion of a population has a certain property, whatever you're looking for. But here's 2 equations that you need to know. The margin of error for the population proportion uses this equation. The margin of error uses the z-score, a z-score. P is the sample proportion, and N is the total sample size. So, 30% of people have blonde hair. 30% would be the proportion of 30 out of 100. 30 be the P and 100 be the N. The margin of error for population mean, if you have an average, is right here. So this is this symbol for average right here on top, and then the square root of the population. And notice the square root's over all of this, but just over the sample size in this down here. We're going to deal with confidence interval in this assignment, in this lesson. So here's the assigned z-scores for the confidence interval. If it's a 90% confidence, it's 1.645. 95%, 1.96. 98, 2.33. Now, it's important to have this in your notes. Either print this page or write down this kind of stuff, because that's useful in the test if you have these notes, because you can use any notes from the test, right? Remember that. So have these things written down because you need to know these z-scores to use these formulas, because these use the z-score right there. You have to know what the confidence interval is to know which z-score to use. So just wanted to show you that this morning. We're going to work a couple of problems together here. So I'll put that up on the screen. My pencil and paper. Okay. So let's look at a problem. Just a sample problem here. Move this problem right over here right now. So this is a fast food restaurant wants to make sure that customers receive their order within 1 minute of arriving at the final window. A random sample of 175 completed orders found that 91% were delivered in that 1 minute. So they looked at 175. So that would be our sample size. That would be our N. And 91% were delivered in 1 minute. Now, see what the question asks. What is the 95% confidence interval for the population proportion? The 95% population. The confidence interval, 95%. So we got to, that's where we have to have that chart written down. The 95% was 1.96 for the z-score, 1.96. So let's see which formula we need. Well, this is the first one. So the margin of error, I'm going to call it the MOE, equals the z-score. Try to write this legibly. My hand's still a little shaky from my chemo treatment. Always does that. And takes months to get back where I can write to get as good again. Not that I write real good anyway. Okay, p times 1 minus p divided by n. So what is that for ours exactly? It's 1.96 times the square root of our p is 91%. So change it to a decimal, 0.91 times 1 minus 0.91 is 0.09, all over 175. So we got 1.96 times the square root of 0.91 times 0.09 times 1.75. So now we're going to need a calculator. Okay, I'm going to start with this under here. For this on-screen calculator, the square root, you got to have the number already calculated and then hit the square root button. So I need to calculate what this number is. So 0.91 times 0.09. Okay, that's what 0.91 times 0.09 is. Oh, I don't have a decimal, decimal 09. And then divided by 175 is that. Now that's what I need the square root of. So I hit the square root button, and the square root is 0.021633. And I multiply that times 1.96. I see 0.04. We can round it down, 0.04. So 0.04. So what that tells us then, it asks what is the 95% confidence interval? 91% plus or minus 0.04 or 4%. With this percentage, which means the confidence interval is between 87 to 95% confident. That's our answer. It's 87 to 95% confidence that these numbers are accurate for the whole. So if we were to expand that to every customer, we're 87 to 95% confident that that is accurate and applicable. So let's look at another problem while we're here. It uses the other type of the same equation. All right, so look at this. A medical study of a random sample of 1,000 patients. Okay, so now we know that our N equals 1,000. Found the mean cholesterol, so the average cholesterol, the mean, which is that little symbol. I'm going to write this down, 212.4 milligrams per DL. So the population standard deviation is going to be 7.4. Okay, 7.4 mgdl. And wants to know what is the 90% confidence interval? 90%. So I'll move that back out of the way. So we need to know the number for the 90%, which would be our z-score. So 90% was the 1.645. So like I said, have that in your notes. See, I got those notes right there. I got my confidence intervals that I wrote them down. And I wrote my two formulas down in my notes. So this time the margin of error equals, we're using this formula, the z-score times z-score times, so a little symbol again, square root of n this time. Okay, and that little symbol stands for our standard deviation. So let's do our z-score, 1.645, and it's times, our standard deviation was 7.4, and our square root of 1,000 goes down here. Okay, calculator time once again. All right, let's clear that last one out. So I need the square root of 1,000 first. Oh, wait. I got to divide it into 7.4 divided by 1,000 square root Okay, so 7.4 divided by square root of 1,000 is 31.6 times 1.645. So it equals 0.38, and we'll round it to 5. So 0.385. Close that out. So when we add that to what our mean was, so 212.4 plus or minus 0.385, right? If it's minus, we're subtracting from that. So our answer is 212.015 because 0.4 minus 3.85 was 0.5. And the high end, we would say it's adding that 0.785. 0.785. So that's an example using each of those two formulas for margin of error. Margin of error. So be sure and read through this carefully. It's real easy to make a mistake if you're not careful. You have to be careful in doing these problems with this. And then in lesson 7, it's about using experiments. And important thing is the terminology in there. Make sure you're learning the vocabulary. Let's see, I'm looking for the summary. I believe is on page 4. All right. Main things. One of the big things to learn: an experiment should consist of the following parts. So the introduction and research question, the methodology, the results, and the discussion. Right. So the parts of an experiment. And bias is introduced through design. And one way to reduce possible bias is through randomization of the control and treatment groups. Let me tell you guys, if you want to have a good career, you can get into statistics, and there's lots of different businesses and lots of government jobs, and lots of people use statistics to try to predict things and try to analyze things. And statistics is a big thing. So it can get very complicated if you're not taking it slow and paying attention to what you have there. But that's all I'm going to show you today. You know what's due this week now. Next week's coming up the test for all of this, for this whole unit that you've been doing on Unit 8. So we're getting right down to the end of that. So if you have any questions, you hang around. Otherwise, have a great week. I'll see those of you with a low grade on Thursday.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.